All right, moving on to 6.5. So different angle, hopefully you can read the word problems clearly. So 6.4, we learned about the distributive property and how to expand that. So the term on the outside distributes onto the other two terms. And then in 6.5, we're going to be looking at solving these things. So are we able to put them into an equation and actually come out with x equals our answer? So we're going to actually solve. So we'll look for a minute about how that looks. So starting with a problem solving kind of situation, here Allison thought of her favorite number. She subtracted 2. Then Allison multiplied the difference by 5, and then the product was 60. What is Allison's favorite number? So just a reminder, when we're problem solving, when we're trying to figure out an equation, we can use that last sentence. It usually gives away what our x is going to be. X is going to be her favorite number. Okay, so setting up the distributive property, what we did in 6.4 is we went back and we looked at what needs to be, where do the brackets need to be in this situation. Okay, so Allison thought of her favorite number. In other words, Allison thought of x. Okay, so starting with a number, x. She subtracted 2. That one's an easy one to set up, x minus 2. Then she multiplied the difference by 5. The difference meaning subtract, right, in math. So then she subtracted, or she multiplied the difference by 5. So she multiplied this whole thing by 5. And so that's where we're going to set up the distributive property. Okay, this is what we would have done in the last section in 6.4. So we would have taken that number on the outside and we learned how to multiply the 5 by the x and the 5 by the, in this case, negative 2, leaving us with negative 10. We've done that in 6.4. Okay, so in 6.5, what we're going to add to that is this last sentence. It says the product was 60. So in other words, after she took her favorite number, subtracted 2, multiplied the whole thing by 5, that equals 60. So anytime we have an equation, it means we have an equal sign. Equation, equal sign. And so we'll actually, in this video, discuss two main ways to actually solve a question like this. Okay, so we'll actually get into the example, and then I'll head back to this, and then we'll solve this in two different ways. Okay, so we're going to actually jump. Example 2 just has numbers, which is always easier than actually coming up with an equation from a word problem situation. So example 2 we'll do first, and then example 1. So this one, solving this situation. And then also, we can't forget, we learned also how to verify, so we'll touch on that at the end as well. So it doesn't matter the order, we have the answer on this side, and then we have the variable and everything else over here. We're used to seeing it the other way, but we can solve it in the exact same way like this. So if I just rewrite that for a minute, 3 and then x plus 4. If we apply the distributive property, which we learned about in 6.4, that's one way to solve an equation like this. Okay, we can multiply the 3 by the x, we get 3x, we multiply the 3 by the 4, we get 12, and then we leave the 14 on the other side. Now, what happened when we did this is now this looks like an equation we've seen in 6.1 and 6.2. It's just a simple two-step equation. We do the opposite operations. We start with the stuff furthest from x, meaning the 12, not the 3, and then we do this in 2 steps from here. Subtract 12, so 14 minus 12 is 2. This is canceled out. And now this is where we get into unfamiliar territory, because when we divide by 3, which we have to do, it's the opposite, 3 times x, so we have to divide by 3. We get our answer, x equals, we could leave it as a fraction, or if you did this, you'd get 0.6 repeat, right? And so we can just leave it as a fraction answer. We're not used to really seeing that so far in math, where we get, we've started seeing negatives now, but we haven't really done much where we're getting a decimal answer. So it's okay, you don't have to panic. We're allowed to get decimal answers. It could still be correct. Okay, so we'll actually verify that. Verify just means plug in your answer, see if it's correct. Okay, so if I did that, if I actually plugged that in, I took my answer as apparently my answer is 2/3. If I just plug it into this, and do BEDMAS, 2 over 3 plus 4, I should get 4 2/3, 4.6 repeat in other words, and then multiply that by 3, and you will find that when you plug that in your calculator, you do get 14, which you should get. So verifying just means to plug in your answer, work through it step by step, and then see if you get what they say you should get. Okay, so verify, yes, that is the correct answer. Even though it's a fraction, it still worked. Okay, that's one way to do it, is actually using the distributive property. Another way is to actually skip the distributive property. In this situation, it doesn't really work super nice, because what ends up happening is we get a decimal early on. Here we didn't get a decimal until the very end. And so sometimes it'll work nicer than others, and you'll see that when we go back to the first example here. But another way to tackle a question like this is to think of it as this stuff in brackets is technically one thing. So I could look at this as 3 times something equals 14, and now we just need to go find that something. And so if we think of it like that, it's really no different than if I have 3 times z, whatever, I'm just changing this to a z, equals 14. If we had to do that, we would just simply divide by 3 and we'd be done. So we can kind of do it like that, except we won't be done. We'll have one other step left. So this way is actually can be kind of a shortcut way in certain instances. So here, if I think of it like that, as 3 times this stuff in brackets, and I'm just going to divide by 3. This is totally legal in math as well. I can take that number in the front and just divide it out. Now what do I get though? This is the problem in this case, is I get 4.6 repeat equals x plus 4. I do have to be careful with that, because I can't just round that to 4.7 because I'll get slightly the wrong answer. So I have to leave it exactly as it is. But you might see already that I'm very close to my answer. All I have to do now is x plus something equals my answer. I'll do the opposite operation. I'll just subtract 4. And that'll leave me with 0.6 repeat. Or what I got in my first answer, 2 over 3. So this one, it is possible to do it, but in your first step, you're going to get a repeating decimal, and so you do have to be careful with that so that you get the right answer. Here, we didn't get it until the end, but both of these ways are totally legitimate ways of calculating an answer where we have brackets in an equation. Okay, so I'm just going to jump back to the first example here, because this one actually works nicer if I'm doing it that second way, right? It works nicer because if I want to think of this as 5 times this whole big something equals 60, and I want to get rid of that 5, if I do the opposite operation and I divide both sides by 5, this will give me a nice whole number. So if it's going to give you a nice whole number, it can be a nice little shortcut to take. Okay, so this is gone. I'm just left with x minus 2 now, what's in brackets, and 60 divided by 5 is 12. Okay, and now it's just one step remaining. So instead of 3 steps, you can sometimes get away with just 2 steps. So x equals 14 would be our answer there. Okay, just to show you that we could also do this the original way, 5x minus 2 equals 60, we could do the distributive property. Now it's totally preference. You can do whichever way you like. Makes no difference. You'll always be able to get it either way. Just sometimes if you're quick and you recognize you might be able to take an easier way depending on the numbers you're given. But again, here's the distributive property, 5x minus 10 equals 60. Add 10 to both sides, and I get 5x, this is gone, equals 70. Divide 70 by 5, and we get the same answer. Good thing you get it the same one either way. That means you're doing it right. Okay? So, 2 ways. So take note, pick the way that you prefer and go to that, especially if you got a quiz or a test. You want to make sure you're comfortable with your way. So both ways will give you the same answer. Okay, so just one word problem example in this section, and then you guys can get to work again. So read through it carefully, identify your X, and then come up with where do the brackets need to be in this situation. So John and Lorraine are landscaping. They're buying pyramidal cedars that cost $12 each. Sounds really cheap. John and Lorraine need 11 to shade their patio on 2 adjacent sides. They would like to purchase as many more cedars as they can for the far end of their lot. John and Lorraine have $336 to buy cedars. How many more can they buy? Okay, so we know that they cost $12 each. We know in the question, how many more can they buy? That's going to be your X. How many more cedars can they buy? They need 11 more, and then 2 adjacent sides they need cedars on as well. Okay, so write an equation. So I know that they cost $12 each. I know they need 11, and they want a bunch more, right? So I don't know how many more they want, but that's going to be my X. Okay, so notice I need to put brackets in here. It's not just 12X plus 11, right? It's not just 12. We need to figure this out. They need the 11 plus the X more. How many more? That's what we're trying to find out. And they have a budget. They have only $336 to spend, so it's going to be equal to 336. So a little bit tricky one. You want to read through this a couple times just to wrap your head around it, but it's $12 per tree. Don't know how many trees they need, but they do have 11 already, so we're trying to find the extra amount, and so that's where the brackets come in. However many they decide is going to be multiplied by 12. That's where the brackets come in. Okay, so a little bit of a tricky one to set up, but once we do, we can take our pick. Okay, I'm going to do it by getting rid of this number in front. I often prefer this, and I think it's going to work out nice because 336 divided by 12 should give me a nice whole number, which it does. Okay, so that leaves me with 11 plus X equals this. When I divide it is 28. And in a word problem question, when we're talking about a number of trees, we actually know it's probably going to be a whole number, because if I got 26.4 as an answer, it doesn't really make sense for the amount of trees, right? So if I wasn't getting a whole number, red flags would be going off, because that doesn't really make sense, right? But if it's nice, seems like it's working out nice, I just have to do the opposite here. So it's a positive 11, so I'm going to subtract 11, and that gives me, hopefully I don't make that mistake, but I think we get 17 trees. Okay, so I've set up an equation, I've solved it, and so I should be able to verify, so basically check that this actually makes sense, that it all works out. So if they bought 17 more trees plus the 11, right, they have 11 plus the 17, that gives 28 trees, and they're $12 each. So if I multiply that by 12, I should get back my original that it says in the question. So indeed I do, I get the 336, so it does check out. I verified it and it works. So you do have to show that when you're asked to verify. Okay, I'll quickly just go through if we did it the other way as well. So if I took this, by the way, it doesn't actually matter which way you have these, right? Because it's just plus, so I could have X plus 11 as well. That would work. I'll just do it the distributive property way for those that prefer that. 12x, 11 times 12, 132, I believe. Yeah, 132. Oh, I should have had an equal sign there. Equals 336. So hopefully you can still read what I'm doing there. Now it's a two-step equation. So we've done the one step, and now we have 2 steps left. Here we pretty much just got away with doing it in 2 steps. Okay. So if I subtract 132 from both sides, then I'll be left with 12x equals, try not to make a mistake here either, 204, and then divide by 12. Okay, so there's my answer. You've worked out again both ways, so take your pick. You've got 2 ways. The tricky part for this section again is going to be setting up the equation, making sure you've got the right equation. Okay, so page 347, some questions to practice there. 5, 6, 8 through 12, 14, and 17.